Rick, why does my code go from fast to painfully slow when the data grows?
Because you ignored Big O, Morty. It's how we measure whether your code survives millions of data points or dies instantly.
But how am I supposed to tell which Big O I'm dealing with?
Look at how your code suffers as the input grows, Morty. That's suffering, that's Big O. Here are some examples. Big O of 1 is constant time, like accessing an array element by index in one step. It doesn't matter how big the list is. This is the best case. Big O of login is logarithmic time. Binary search on a sorted array. You cut the problem in half each step so it grows slowly even with huge inputs. Big O of n is linear time, like searching through a list, one item at a time, usually represented with a simple for loop. Twice the data means twice the work. Big O of n squared is quadratic time, usually nested 2 for loops, essentially comparing everything with everything else, like checking duplicates in a list. This gets slow very quickly. But one of the worst is Big O of 2 to the power of n, which is exponential time. It is brute forcing all combinations, works for tiny inputs but collapses instantly on anything bigger. Algorithms are judged by these patterns.
So, Big O is basically how much worse things get as the input grows?
Exactly. Big O shows how your algorithm behaves when the input gets huge. Two solutions can look the same on small data, but only Big O tells you which one scales as the input gets large. Hardware, caching, and languages change the details, but the growth pattern never lies. It's how you tell efficient code from code that falls apart. Drop a function and I'll tell you it's Big O in the comments.